So Amy, in this film we're going to discuss how early life experience can affect food choice. When we use the phrase early life experience, we might think about things that happen in childhood and how that affects us in later life. Is there any evidence for that?
In terms of food choice, flavour learning is a really good example. So when I was a child, I grew up near the sea, so we ate a lot of fish, and I still really love seafood. But artichokes, on the other hand, I really can't stand, and I don't think there were many around when I was younger. But if we look at this in a more scientific sense, there is actually evidence that the flavours we experience when we're younger, in our childhood, can influence our food preferences later in life. And one good example of this is flavour learning, and we can look at this in terms of interventions to increase vegetable consumption in children. So we all know that vegetables are good for us, but it can be quite difficult to get children to eat them sometimes. But one thing that has proven really effective is simple repeated exposure to a vegetable. So repeated exposure can actually increase the consumption of this target vegetable, and eventually it can also lead to sort of a preference for that vegetable. And these preferences we develop in our childhood will actually carry on through into our adulthood as well.
So there's evidence that experience in childhood can have long-lasting effects. What about further back into pregnancy?
Prenatal flavour learning will be an example of these effects occurring during pregnancy. So there is evidence that the food a mother consumes during pregnancy can actually influence the offspring's preferences later in life. One experiment that illustrates this used carrot juice. So a group of pregnant women consumed carrot juice 4 times a week for 3 weeks during the final trimester of pregnancy. And their children, once born, actually showed fewer negative reactions to cereal that had been soaked in carrot juice compared to those children whose mothers hadn't drank the carrot juice during pregnancy. This is thought to occur because flavour molecules in the food consumed by the mother can actually end up in the amniotic fluid, and this is then swallowed by the fetus. As taste buds develop very early on in pregnancy, between 12 and 15 weeks, this could explain how these flavours are able to influence the offspring's food preferences later in life, as they learn to accept the flavours they experience in the mother's amniotic fluid. So this highlights the importance of maintaining a varied diet during pregnancy.
So what's the evidence for prenatal nutrition more generally?
To understand this, we need to look back at the work of David Barker. He was an epidemiologist who in the 1990s proposed that there was a link between the environment the fetus experiences and their health later in life. Importantly, he suggested that the prenatal environment could be influenced by the mother's nutrition. Barker realised that areas in the UK that had high areas of infant death were the same areas that experienced high death rates from coronary heart disease decades later. Around this time, the most common cause of infant death was low birth weight, and this suggests suboptimal conditions in the womb. This led on to Barker establishing a link between the prenatal environment, and in this case, maternal malnutrition, and coronary heart disease. He then went on to propose the thrifty phenotype hypothesis. The underlying idea of this is that the fetus is born adapted to the uterine environment, but as we grow in age, this environment can change, and the adaptations that are in place can lead to problems. For example, if a fetus experiences undernutrition, they may undergo physiological changes that drive food intake when food becomes available. In our modern food-rich environment, you can see how this might lead to weight gain.
So you've talked about undernutrition. What about overnutrition during pregnancy?
Well, as maternal undernutrition can predispose to obesity, if we look at Barker's hypothesis, we might expect that maternal overnutrition could lead to the opposite. But actually there's evidence to show that maternal overnutrition also predisposes to obesity. So rodent studies have shown that if a mother is fed a high-fat, high-sugar, junk food-style diet, her offspring will then be predisposed to prefer these sorts of flavours, similar to the flavour learning I discussed earlier. And this can lead to a higher predisposition to obesity. Furthermore, there's evidence to show these effects can actually pass down through several generations. So I've already described the effects we see in the programmed offspring. These effects can also be seen in their offspring. This suggests an epigenetic influence of prenatal programming, and that it can actually be passed down through several generations.
So much of the work you've talked about so far was done in animal models. Are there any parallels with the human population?
Clearly there are ethical limitations to doing the sort of studies I've talked about on humans, those on malnutrition for example. So what we tend to do is take evidence from case studies of naturally occurring events to look at these effects. In terms of malnutrition, one good example is the Dutch famine. So this occurred in 1944 during the Second World War, when German blockades prevented the transportation of food and fuel shipments from farm areas to the densely populated western provinces of the Netherlands. This famine had a very sudden onset and resolution, unlike many countries which suffer from chronic famine, which makes it an ideal case study to look at the effects of malnutrition on a usually well-nourished population. As well as this, we have excellent birth and medical records from the time. And looking at this, scientists are actually able to see that those children that were in utero during the famine had much higher levels of obesity compared to those that weren't in utero during the famine. Furthermore, these effects also appear to pass through up to 2 generations, as offspring of women that were in utero during the famine also had much higher levels of adiposity compared to those that weren't.
So as well as nutritional effects, there's a lot of work being done now on the effect of stress during early life. Can you tell us first a bit about how stress affects eating?
We'll actually discuss that in more detail in this week's Mootcast. But briefly, stress can have a big impact on both how much we eat as well as the food choices we make. It can vary quite a lot between individuals, but generally people can split into one of 3 groups: those that increase their food intake when stressed, those who decrease their food intake, and those for whose food intake remains the same. As for food choice, it's generally thought that during periods of stress, people increase their consumption of foods high in fat and sugar, but this can again vary quite a lot depending on the individual.
So what about the long-term effects of stress during pregnancy?
So the effects of stress on feeding behaviour have been quite well established, but recently attention has turned to prenatal stress and how this can impact on the offspring. There is evidence to show that stress during pregnancy can have a programming effect on the fetus. Rodent studies show that prenatal stress can lead to an increased stress response, as well as some metabolic and emotional problems, such as increased anxiety. Given the link between stress and food choice, it's worthwhile asking whether prenatal stress can also impact on our feeding behaviour.
So we've discussed a lot about mothers, but everyone has 2 biological parents, of course. What about fathers?
Well, despite the fact that it's the mother that actually carries a fetus, there is evidence to show that the paternal side can also have an influence on the offspring's physiology. Much less research has been done in this area.
So taken together, there's strong emerging evidence that poor nutrition and stress are associated with problems in later life.
That certainly seems to be the case. And most importantly, perhaps, all of these problems, poor maternal nutrition, maternal stress, they can be prevented, so these problems can be solved. This is a quote from David Barker. "These diseases are not mandated by the human genome. They barely existed 100 years ago. They are unnecessary diseases. We could prevent them had we the will to do so."